In this video, we'll implement our learnings and build a currency converter application. In doing so, we'll dabble with a lot of React concepts and features such as class and function components, state, controlled form components, lifecycle methods, and querying an API. Let's get right to it. This is going to be a fun video where we'll build a currency converter application that calls the openrates.io API for fetching and displaying currency rates. We'll build the application from scratch, except the style sheet which I've pre-built for you, among a few other things. But first, let's see what the completed app looks like. We have two sections in the app, let's call them from and to. The from input field is the one on top, while the bottom one is the to input field. The simple idea here is that a currency value is converted from a user typed amount to the converted value. So when I type an amount in the from box in US dollars, it instantly gets converted to a value in Indian rupees. But the inverse is also true. The app lets you type an amount in Indian rupees and its USD equivalent is computed and displayed in real time. This way, we effectively reverse the roles. You can also change the from and to currency symbols by using the drop-down menus. Upon doing so, the latest conversion rates are fetched and you can instantly see the conversion value update. For instance, 50,000 Singapore dollars is equivalent to 36,018 US dollars. This is a minimal app, yet is a great example to build. So let's get cracking. As always, begin by downloading and extracting the project archive from this link. Then run npm install to download and set up dependencies. And finally, run npm start to get the hot reloading server up and running. Our app component is a class component that currently renders a div on the page. Let's begin by modeling our state object first. The first two properties, from and to, are used to set the symbols for currencies that you wish to convert between. So by default, we are converting a value in US dollars to Indian rupees. Based on the choices you make, we'll update these properties and use this change to trigger a function that fetches new rates from the API. The next property, named rate, holds the conversion value. For instance, if 1 US dollar is equal to 70 Indian rupees, then the value of rate would be 70. The last two properties, from AMT and to AMT, will hold the value of the two input fields that we'll create to let the user type in a value. Since our app has two identical input sections, one on the top and one below it, we'll build a reusable component called currency input first. Here I'll create a div with the class name field which will hold two input elements. A currency picker, select element, where I'm going to hard code some currency symbols like so. Next, we'll create an input field with the class name number input, and this will be of the type number because we want users to type in numeric currency values here. Let's export this and bring it in our app component first. I'll create two instances of this component like so, which gives us our UI as desired. We now need a way to turn our select element into a controlled element so that it syncs with the from and from AMT properties in our state. For this, I'll first declare two props, namely symbol and select symbol. As you may recall from the controlled components video, we need to bind the value attribute to a state or controlled source along with the onChange event listener. In this case, we'll set the value to the symbol prop, and the onChange listener should invoke the select symbol prop as a function and pass up the selected value from the dropdown. Back in the app component, we can then set the symbol prop to this.state.from and the this.state.to properties respectively for our two instances of the currency input component. When I save and hot reload the file now, You can see our select elements are now synced with the from and to state properties. To update these properties when someone picks a different currency symbol, we'll then use the select symbol props to set these state properties like so. Now, I have the React DevTools installed in my Chrome browser. This utility can be installed from the Chrome store and is great for debugging and peeking inside your React apps as it gets developed. I'll go into the components section where I can see my component hierarchy. Selecting the app component here shows me the state variables in real time. If I now pick a different symbol, you can see our state properties update as expected. Back in the currency input component, I'll repeat the process for the input element as well, where we'll use a prop named amount and set amount. This time, however, we'll handle these two props in a different way. First up, for the set amount prop, which will run every time a user types in one of the input fields, we'll invoke an instance method named setAmount, where we'll pass the amount value that the user has typed in, and we'll also indicate which specific input field it is coming from. We'll then create the setAmount function. Here, if the incoming value is coming from the input field at the top or from, we'll set the from AMT to the value of the input field and we'll set to AMT to null. Why are we doing this? Just stay with me and all shall be revealed in a moment. Now, if the value is coming from the to field, we'll set the to AMT as the value with from AMT as null. The null here helps in identifying which of the two input fields is active. You'll see this in action in just a bit. To set the values to the input elements, we'll use an instance function named computeResult, which we'll build in a moment. To get the right value, we'll pass in a keyword to identify the input field. The computeResult function is the most important function in this example as it does the actual computation and the value conversion. Here we'll first extract the values of the from AMT and to AMT from the state. If the user is typing in the from input field at the top, then its value would not be equal to null. If that is the case, we'll set the to AMT by multiplying the from AMT value with the conversion rate. So if I type 10 in the USD box, it should multiply that with the conversion rate and give me a value in the to AMT input field at the bottom. Do note that we are not setting the state properties to AMT and from AMT here. We are simply updating values in a variable inside the computeResult function. State properties should only be set using the setState method and not directly. Now, if the user is typing in the to AMT field at the bottom, then from AMT would be set to null. In this case, we'll compute the value of the from AMT by dividing the value that the user is typing in with the conversion rate. But this alone does not set the value of the input fields. Remember, we are setting the amount to an invocation of the computeResult function. So we need to return a value here. Our return statement checks the value of the key argument in the ternary operator. If the from field is seeking a value, then the value of the from AMT is returned. So if the user is typing in the from field, that value would be returned directly without any changes, turning the from field to a controlled component. As this happens and the component re-renders, the to field will demand a result as well, in which case it will be set to the computed value of to AMT, where we are multiplying from AMT with the conversion rate. On the other hand, if the user starts typing in the to field at the bottom, the from AMT is set to null, in which case the value of to AMT is passed on as is, but the value of from AMT is computed and returned after dividing the to AMT with the conversion rate. Take a moment to analyze this function again, as it might be a little confusing at first. By identifying the active input field, we are switching the values to raw input values or computed values. You can see if I type values in the fields, the other field updates automatically, but the values are the same since our conversion rate is set to 1 by default. So let's get actual conversion rates from the OpenRates API. The API script is included with the project setup, so let's import the script in like so. The OpenRates module simply exports a function which accepts a base symbol and a target symbol and uses the OpenRates API to fetch and return the conversion rate. This API is free to use but has some limitations which you can read about on the openrates.io website. Let's now create an instance function called fetchRates, which will be an async function that takes in a base symbol, which we'll set as default to USD, and a target symbol, which we'll set to default as INR or Indian rupee. The function then uses the await keyword to query the OpenRates API, passing the desired symbols, and uses setState to set the value of the rate property. But how and when should we run this function? There are two events where we need to run this function. The first is when the application loads and we need to fetch the default and initial conversion rate. We can achieve this by using the component didMount lifecycle function, where we'll simply run the fetchRates function passing in the default symbol values from the state. Now when the app loads up, you can see 1 USD is equivalent to 71.67 Indian rupees at the time of this recording. This would differ in your case as these rates are always in flux. As I change the value in USD, the resulting value is displayed instantly in the field below. On the other hand, if I type a value in Indian rupees, the USD equivalent is computed as well. There's just one problem though. If I change symbols now, nothing happens and the rates are not fetched. The change of symbol simply updates the from and to state properties, which means that the component re-renders, but we are not running the fetchRates function to get updated rates as per the change in symbols. To achieve this, we can use the component didUpdate lifecycle function. But this lifecycle function runs every single time our state properties update. We don't want to run the fetchRates every single time. This is why we'll perform a check to see if the from or to properties have indeed changed or not between successive re-renders. Only if they have will we run the fetchRates function again. This optimization is essential to prevent a series of never-ending re-renders that can cause the app to crash. Let's test the app now. I'll change the symbols and amount and everything works exactly as desired. This small project saw us implement a ton of React features, from using both class and function components, state properties, controlled components to using lifecycle methods for querying an API and more. There was a lot achieved in this project. I hope you found it useful.